In the future of anti-aging science, the landscape will evolve into a dynamic fusion of pharmaceuticals, biotech innovations, lifestyle medicine, psychological optimization, and wearable tech. Among these, senolytic drugs, designed to selectively eliminate senescent cells, are poised to become a cornerstone of preventive aging interventions. The promise is compelling. In animal studies, these compounds consistently rejuvenate tissues, reduce chronic inflammation, and improve physical function. Early human trials, particularly combinations like dasatinib and quercetin, are already being explored for their efficacy in conditions ranging from idiopathic pulmonary fibrosis to neurodegeneration. Researchers are increasingly optimistic that senolytics could do more than treat disease; they could preempt it entirely, offering a pharmacological approach to maintaining health span alongside lifespan. With sufficient refinement, particularly in minimizing unintended cell clearance and tissue-specific effects, these drugs could one day be taken annually or biannually like vaccines, especially for individuals at risk of age-related decline. Importantly, future iterations may become more targeted, sparing beneficial senescent cells while removing only those that actively promote tissue dysfunction. Pharmaceutical development won't stop at senolytics. The emerging class of xenomorphics, agents that suppress the harmful signals released by senescent cells without destroying the cells themselves, may be used in tandem with senolytics to fine-tune tissue microenvironments. Meanwhile, NAD+ precursors like NMN and NR are already showing potential to restore mitochondrial function and cellular energy in aging tissues. As these compounds become more bioavailable through delivery innovations, such as liposomal encapsulation or mitochondrial-targeted prodrugs, their impact may deepen. Rapalogs and TOR inhibitors and AMPK activators, both of which modulate nutrient-sensing pathways linked to longevity, will also gain ground in tailored longevity protocols. Precision aging medicine may emerge as a specialty, where patients are prescribed specific anti-aging pharmacological stacks based on biomarkers, genetic risk factors, and biological age assessments. Biotechnology will advance in parallel, possibly even outpacing pharmaceuticals in terms of sheer transformative potential. Gene editing tools like CRISPR will likely be adapted to repair accumulated DNA damage or enhance protective genes like FOXO3 and Clotho. Partial cellular reprogramming, using Yamanaka factors or related interventions to reset epigenetic age without causing dedifferentiation, will grow from proof-of-concept animal studies to refined clinical trials. The ability to reverse tissue aging without inducing tumors will be a keystone in regenerative anti-aging. Stem cell therapies will also become safer and more standardized, shifting from exotic boutique offerings to regulated, mainstream treatments. Autologous cell banking, where young cells are stored for future rejuvenation, may become common practice for those in their 20s and 30s, offering insurance against future decline. Lifestyle medicine will remain foundational, but with far more precision than today. Wearable technology will move beyond tracking steps and heart rate to become true biofeedback devices. Future wearables will continuously monitor molecular markers such as blood glucose, inflammatory cytokines, cortisol, and perhaps even levels of senescent cell burden via circulating SESB factors. These insights will allow users to adjust their activity, sleep, and food intake in real time for optimal aging. AI-driven coaching systems will analyze years of personal health data to deliver micro-adjustments, encouraging a morning walk, recommending a fasting interval, or identifying sleep phase disruption before fatigue is felt. These systems may even interface with smart homes, adjusting lighting, temperature, or noise to optimize circadian rhythms and emotional well-being. Psychological resilience and cognitive training will also be recognized as major anti-aging levers. The emerging science of psychobiological aging suggests that chronic stress accelerates telomere erosion, inflammation, and immune aging. Meditation, mindfulness-based stress reduction, and cognitive behavioral therapy may be repurposed not just for mental wellness, but as core longevity interventions. Digital therapeutics and virtual reality platforms could gamify mental rejuvenation, offering immersive neurofeedback or cognitive training environments that are both enjoyable and effective. Language learning, music, and social engagement platforms will be reframed not only as hobbies, but as synaptic maintenance tools, essential for neuroplasticity deep into older age. Nutrition will evolve into a highly personalized science, supported by machine learning and gut microbiome sequencing. Rather than generalized dietary advice, people will receive food recommendations that match their epigenetic age, metabolic profile, and microbiota composition. Some individuals may benefit from intermittent fasting, while others will do better on time-restricted eating or protein cycling. Postbiotic supplements, compounds derived from beneficial microbial activity, may become as common as multivitamins. Entire culinary traditions may be reinterpreted through the lens of longevity, combining ancestral knowledge with cutting-edge nutrigenomics. On a broader scale, the societal perception of aging itself is likely to shift. Aging will no longer be seen as an inevitable decline, but as a process subject to ongoing negotiation, modulation, and in some cases, reversal. Medical systems will begin to adopt biological age rather than chronological age as the primary predictor of risk and resilience. Health insurers may eventually incentivize proven anti-aging behaviors or pharmacotherapies, and companies will invest in employee longevity as a productivity strategy. By 2040 or sooner, lifespans beyond 100 years could become increasingly common, not with frailty, but with vitality, independence, and purpose. While full cures for aging remain distant, the convergence of disciplines offers a future where growing older no longer means losing capacity. The lines between medicine, wellness, and technology will blur, giving rise to a proactive, data-driven, and deeply personal approach to long-term health. The greatest achievement may not be simply living longer, but aging with grace, functionality, and joy, supported by the very tools that science, nature, and human ingenuity have made possible.